Arif bin Zamri. And so for right now, I will explain question number 1, the manual and simulate. Alright, so for question number 1, A1, for the manual, I get the equation is type homogeneous equation. It's in first order differential equation, and also this is the answer for manual. I will show you for the simulate. Alright, so for the simulate, I use since variable x in term of variable t, ODE equal t times differential x in terms of variable t equal to bracket 3 times t the power of 2 minus x the power of 2 under bracket divide t minus 2 times x and y solve t equal d differential solve ODE, and I get the answer for this. Alright, this is the answer. Right, so for the simulate is a bit short, and for the answer for the manual is a bit long. Alright, so for the question 1A, number 2, I will explain for the simulation and manual calculation. Alright, so this I get the for this question, this answer, and for this question is exact equation, and it's still a first order differential equation. Alright, so I will show you to the simulation. Alright, so for the simulation, I use two variable, is it x and y. Then I declare the m equal to 1 minus 2 times y minus x. And then I declare n equal to negative 4 times y minus 2 times x. And then I differentiate m y, I get negative 2, and differentiate n x, I get the differentiate negative 2, same like m. So is it the exact equation? And then I will use w equal to int mx, so I get this answer. And then I use r differentiate wy, and I get negative 2 times x. And then I use declare s equal to n minus r, I get negative 4 times y. And then I use t equal int s y, I get this answer, negative 2 times y power of 2. And then I will get the answer for g minus w plus t, and this is the answer. It is same just like manual calculation, but for the simulation it's a bit longer for exact equation. So for the question 1b, I will show you for this for this solution, which the initial value y2 equal to negative 1 is for this answer. Alright, so I have done that question for manual, and I get this for the answer. So let's go check for the simulation. Alright, so for the simulation, I use sims y in terms of x, ODE equal y times x times differentiate y in terms of variable x equal to 2 times bracket y power of 2 plus x power of 2, and condition equal to y 2 equal to negative 1, and y of x equal to differential solve ODE con and I get this for the answer for the simulation, and it was correct, which is which manual calculation, but it's a bit different because maybe I use a simple. This is the expert. Alright, so for the next question, C1, I will rearrange the following differential equation in the form this and solve all the equation. So for the C1, I will show it to you for the manual calculation first. So for the manual calculation, I get for this answer. Then I will show you to the simulation equation. Alright, so for the simulation, I I use sims y in terms of variable x, and then for the equation, I declare ODE equal to x the power times differential y plus y power of y equal exponent x, and then I will solve it. Y solve x equal to this of ODE, and y solve this of ODE. So I get this answer, and it was the same just like a manual calculation. Alright, so for the last question, or for question number 1, C2, I will show it to you for the manual and question and simulation question use MATLAB. So for the C2, so this is for the answer for the C2, and I get this. I get this answer. I will show it to you for the simulation. And for the simulation, firstly, we have to declare the sims y in terms of variable x, and then declare the equation ODE equal differential y plus y times sin x equal to equal sin x, and then we will solve it. While solve x equal to this of ODE, then this is the answer for the simulation, and it was the same answer just like manual calculation.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Abdul Ghani, and my number metric is DE1120379. Okay, today I will to continue our presentation about the manual calculation and simulation calculation using Maple. Okay, and I present for the question 2. Okay, we go to the manual calculation first. Okay, the question is calculate the general solution using the method undetermined coefficient. Okay, first of all, we need to find the root from the question, and we can find it is case 1. It is because M1 and M2 is not same. Okay, next, we need to find YP, and YP is Cx exponent to x. Next, we need to define Y prime P and Y double prime P. And to find to this, we need to do the product rule for the YP to get the answer. And then we get Y prime P is 2cx exponent to x plus c exponent to x, and the answer for the y double prime p is 4cx exponent to x plus 4c exponent to x. So it is the y double prime p. Okay, after we find yp, y prime p, and y double prime p, we need to substitute the this to the solution. So after we substitute the y double prime, y prime and y, after we substitute this and we solve and we get c equal to 1/7. Okay, so the answer of the ypx is 1/7 exponent 1/7 x exponent to x. So for the general solution, it is yx equal to ycx plus ypx, and after we substitute the answer and we get a exponent to x plus b exponent negative 5x plus 1/7 exponent to x. So it is the manual calculation for the undetermined coefficient. So we go to the maple for the simulation calculation. It is the same like the manual calculation. First of all, we need to find the root and we define the yc. After that, we find the yp, y prime p and y double prime p. After that, we substitute the all this to the question and we get the answer. It is the same for the manual calculation. Okay, next we go to the second question. It is B, and it is the variation of parameter. So from the question at above, it is same. First we need to define the root of from the question, and then we need to find the fx and a, and the fx is exponent to x and the a is 1. After that, we find the yc from the root and we get a exponent to x plus b x exponent negative 5x. After that, we need to find y1 and y2 and we get this. After we get this, we do the Wariskian solution. Okay, this we substitute y1 and y1, y2, y double prime 1 and y double prime 2, and after we solve it, we get the answer is negative 7 exponent negative 3x. Okay, next we need to find u and v. So the formula is negative integrate y2 fx over aw dx plus a. So we substitute all the point given from above and we get 1/x plus a is u. Okay, next v. To find v, we need to use the equation integration y1 fx over aw dx plus b, and we substitute the point from above and we get negative 1/49 exponent 7x plus b. After we get u and v, we substitute all the answer given from the y equal to u y1 plus v y2. So we substitute it and we get the general solution of the answer is exponent bracket 1/7x minus 1/49 plus a exponent to x plus b exponent negative 5x. Okay, so we go to the simulation for the variation of parameter. It is also same for the manual calculation. First, we need to define the root of the question. After that, we need to find YC, and we need to find Y1 and Y2. After that, we do the Brown scale, and after that, we need to find U and V. And after that, we substitute U and V and Y1 and Y2 for the general question, and we get this. Okay, that's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dina Hafiz bin Sulaiman, DE11203. I will continue for the question 3. Okay, for the question 3, given a non-homogeneous system of the first ODE as shown above. Okay, so for the manual question and for the software simulation, it's just the same. So for the manual calculation, I will write down the question, which is y1 equal to negative 10y1 plus 10y2 plus 5. y2 5 equal to negative 20 over 3 y1 plus 98 over 15 y2 plus 10 over 3. Just same with the simulation, I just write down the question in here. Okay, for the A, the question in it evaluate the general solution of homogeneous system. Okay, so from here, manual calculation by prime equal to ay plus g. For the simulation with linear algebra, just enter the question here. It's just the same with the manual calculation, and then write down the character polynomial, just the same with the manual calculation. So as you can see here, to calculate for the character polynomial, just use the calculator, menu, press A, and enter the polynomial section and select the degree 2. Okay, so for the character polynomial, lambda power of 2 is equal to 1, and then 52 over 12 lambda, and then 4 over 3. Okay, so we get the same number, same with the simulation and also for the calculation, and then the value is just the same. Okay, after that we go to, we want to find the y1, s1, y1, s2 and y2. Okay, for the simulation we insert the coding, which is with linear algebra, and this is the equation. So from here can see here A, which is negative 10, 10, 20, negative 20 over 3, 98 over 15. It's the same with the with here. So for the equation 1, this is the coding for insert the value from here. Eigenvalue A and insert from to here. After that, we get the value for the y1 and also x1. Just the same with the manual calculation. From here, v1 we get 1 over 0.9559. So to determine if the number is the same, we just simply calculate. Okay, so for the number is just the same. Okay, after that we want to find for the v2. Okay, so from here the v2, we from the manual calculation we get 1 over 0.6974. Okay, from here we get s2 at 1 and y2 is this equation. So if we check the number, if it is 2 or not. Okay, so we get the number just the same with the manual and also for the simulation. Okay, so we get the v2 for the simulation. After that, we get to determine for the yc. So to insert the yc number, just with this equation, see here yc a 1 over 0.9559 exponential negative 0.441x plus b 1 over 0.6974 exponential negative 3.026. Okay, after that we go to the question B. Determine the particular integral for the non-homogeneous system. Okay, first we need to assume yp. Okay, this is for the g and this is the yp. So for the yp, we need to differentiate the yp. So after we differentiate the yp, we get 0 over 0. Okay, so this is the equation we get, that we want to get the yp. Okay, after that we go to C. Formulate the general solution for the non-homogeneous system. Okay, y equal to yc plus convert yp matrix. Just the same with this, y equal yc plus yp. Calculate position for the y1x and y2x with y0 equal to 1 over negative 1. This is the equation that we have to use to find for the y. Okay, from here you can see this is the equation 1D, c1 plus c2 plus 1 over 2 equal to 1. If you can see here, for this equation and also for this equation, you can solve it with the simulation equation. Okay, so if we enter the equation 1D and equation 2D inside the calculator, you will get this number. Okay, for the A, this is the solution for the A from same with the manual calculation, and this is for the B. After that, we get the last solution. Okay, this is for the answer. To check whether the answer is true or not, so we just insert the number in the calculator. Okay, from here we get negative 5.2165, and the manual calculation for negative 5.2176. The number is just the same, not the same but near the number. Okay, the bottom we get negative 4.98668. It almost the number same with the calculator and also the manual calculation. For the exponential, okay, we get the same number. After that, we go to the here, we get the 3.9866, almost the same with the manual calculation. This is for the B, we get 5.7165, almost the same. This is for the exponential, we get the same, almost the same number, negative 3.026. Okay, I will pass to the next member to explain about the question 4.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Zainal Abidin. My metric number is BE11203. Today I will be presenting about ordinary differential equation assignment question number 4. So the first one is the Laplace transform of ft equals to 2 exponent negative 3t sine 4t. This one is very simple. You just need to do the Laplace of sine 4t, which is equals to 4 over s square plus 4 square, and then you just simply add the exponent 3t, so the constant is still out because we don't Laplace the constant, and then the exponent will become to s plus 3 square, like this one, because it s to the power of 3 exponents, so it's 3 here. So 2 times 4 is equals to 8, and then 4 square is equal to 16. So 8 equals to s plus 3 square plus 16. So this is the answer. And then for the MATLAB simulation, so for the question 4a, we just need to declare sims s and t because it's Laplace. It uses t and the answer usually have s. So Laplace, so this is the equation, 2 times exponent power of negative 3 times t, and then times sine 4 times t. So this one is to make the answer prettier. So we run the code and we get the answer here. So it's 8 over s plus 3 square plus 16. This one is the prettier version, and it's the same to this answer. And then the second one is ft equals to 3 exponent negative 3t h bracket of t minus 2. And then first thing first, we just need to make it become 2 like this. so it's negative 3 times 2 is equals to negative 6, so it's exponent negative 6, and then exponent times negative 3 times t minus 2 is this one. So we make it 2 like this, we separate it, and then later we compare them. So first thing first, we just need to Laplace the 3 exponent negative 3, this one, this part. So after you take the constant out, you can Laplace this exponent negative 3, so it will become 1 over s plus 3, and then 3 just times with 1, and then it will become 3 over s plus 3. So this is for the 3 exponent negative 3t. And then for the second part, this one, the separate one, and then we take out the exponent negative 6 because we want to Laplace the t, like this t. Yes, and then after we Laplace this, we will get the exponent negative 2s, and then we add these two, it will become exponent negative 6 minus 2s times with 3 over s plus 3, and then we just add it here, and then it will become 3 exponent negative 2 of bracket s plus 3 over s plus 3. So negative 2 bracket of s plus 3 is just this one, it's the same. We just factorize this. So to the MATLAB simulation, we need to declare sims s and t, and then we Laplace the equation. By the way, h is mean heavy side, the h in the question. So simplify a, and then this one to make the answer pretty. So the answer is 3 times exponent negative 2s minus 6 over s plus 3. It's the same. This one is the prettier version. So this is the same to this one because we just factorized it. If you don't factorize it, it becomes negative 2s minus 6 like this. So it's the same as this one, negative 2 times s minus 6. And then for the question number 3, a series RLC circuit is shown in figure Q4b where R is equals to 4, L is equals to 0.5H, C is equals to 0.1 F, ET is equals to 10 volt, and then I is equals to 0. Determine the current IT for the circuit using Laplace transform. So we are finding the current. So first thing first, we need to declare the R is 4, it's given, so 0.5 Henry for L, and C is 0.1 Farad. So the E is equals to 10 volt, and the I is equals to 0 volt. So this is the circuit. Step 1, we just need to do this one, which is L equals to di over dt, which represent di, and then Ri and plus 1C, like this one. So step 2, we just insert the value. So L is equals to 0.5, R is equals to 4, C is equals to 0.1, and then after that we just need to multiply it, like 0.5 times 4 is equals to 8, 0.5 times 0.1 is just 20, and then this one is 20, 10 become 20. We just need to multiply by 2, and then this one, this part, which is S I bracket of S negative I0 plus at I S plus 20 IS over S. So we will get 20 over S, and then SI S plus 8I S plus 20 IS over S equals 20 over S. I is equals to 0, this one, this part. And then we're gonna solve it like this. S plus 8 plus 20 over S equals to 20S, 20 over S. And then we just simply make it the same denominator, which is S, like this. And then it will become 20 over S square plus 8S plus 20. And then this one, this part, we factorize it, so it will become s plus 4 square and then plus 2 to the power of 2, and it will become like this, 20 over s plus 4 square plus 4. So the I is like this. So it's 20 over 2 exponent to the power of negative 4 sine 2t, and 20 over 2 is just 10, so 10 exponent to the power of negative 4t sine 2t. So we are going to the MATLAB simulation. First thing first, we need to declare S and T, and then R is equal to 4, L is equal to 0.5, C is equals to 0.1, E is equals to 10 over S. And then A is equals to inverse Laplace of the equation. The equation is this: E times S over L times S to the power of 2 plus R times S plus 1 over C. We simplify the answer and we make the answer pretty. So the answer is 10 times sine 2t times exponent negative 4t. It's similar to this one, which is 10 times sine 2t times exponent negative 4t, but I write the exponent first. Either way is fine, we can write the sine first and the exponent first. Like this one. This one is 10 times sine 2t, so it's 10 times sine 2t, and then times exponent negative 4t times exponent negative 4t, so it's just the same. So I think that's all for my presentation. Thank you very much.